Hi, my name is Sebastian. Welcome to the second part of the videos on oscillations with phyphox. In the first part of these videos, I've shown you some spring oscillators. I've shown you damped oscillation and how to measure the resonance of a driven oscillator just with phyphox. So if you've missed this, have a look at the description below the video. Those spring oscillators are usually more demonstration experiments because you usually just don't have a suitable spring at home. So in this video I will concentrate on pendulums that you can build with just a piece of string and your smartphone. So let's start with a simple example that you can show off anytime. First of all, you will need phyphox, which you can get for free on Android and iOS from phyphox.org. Open the pendulum experiment in phyphox, switch to the length tab and select the timed experiment function from the menu. Set a start delay of 3 seconds and a duration of 10 seconds. This means that after pressing start, phyphox will wait 3 seconds before actually measuring and it will automatically stop 10 seconds later. Attach a string to your phone. Press start and let your pendulum swing long enough to exceed the 3 plus 10 seconds. Then have a look at the result. If everything went well, you will see that phyphox figured out the length of your string from the pivot point to the center of mass. Just keep in mind that it's your phone that's swinging there, so don't overdo it and make sure not to drop it or hit it against something. But if you're careful, this is a nice little demonstration based on a simple model for a pendulum. So the square of the angular frequency of your pendulum equals the Earth's acceleration over the length of your pendulum. If you want to do some more accurate measurements, you will run into a problem though. With only a single string, your pendulum will tend to rotate a lot, even with a more elaborate construction. Instead, let's build a swing. You can build one from a simple paper tube. Just flatten it a little and punch holes into the 4 edges. Mark the width of your phone and cut the sides. Thread a piece of string through each side and secure the phone with a rubber band. This pendulum will not rotate about the string. With a good pendulum, you could do it the other way around. You could first measure the length of your pendulum with the tape measure and then let phyphox determine Earth's acceleration. Or you could do what we did in our Physics 1 lecture and collaborate to verify the simple model for a pendulum. The students were awarded bonus points for an extra assignment. Build a pendulum and measure its frequency with phyphox. Of course, we also encouraged them to create a short video clip so we could get a glimpse at their creativity. At the time when they did the assignment, they had no idea how the pendulum frequency depends on the length of the pendulum. But instead we just told them to submit the string length along with the measured frequency to a web form. Of course, the experiment did not have the length tab, so they had to measure the length with the tape measure. In the next lecture, when they learned about the pendulum, we put together the results of their submissions. And they matched the theory very well. This is the great thing about these simple experiments. Everybody in the classroom or even an entire lecture hall can be part of the experiment. So with that, I'd like to leave you here. Let me know if you have some nice ideas for other experiments. Thanks for watching and see you next time.